Hi, my name is Piotr Wykowsky, and I am the IoT evangelist at Transition Technologies PSC. Today, I would like to talk about how Apache Ignite is helping ThingWorx, the enterprise IoT platform, handle tens and even hundreds of thousands devices connected in an IoT world. Few words about me. For the past few years, I've been working on IoT solutions for various industries and markets, including energy, pharmaceutics, manufacturing, and many more. My areas of interest are DevOps, which helps us reduce the time to market, and infrastructure to make sure everything works according to plan, especially when it comes to the performance. I have a strong technical background. I have a master's degree in computer science, and since 2010, I've been practicing clean code and clean architecture methods and techniques. I really like sharing the knowledge. I help new hires get on track, introducing them to ways of working and technologies and tools I use every day. I did few talks at tech conferences, and you can find me on my socials, LinkedIn, Twitter, or simply drop me an email at ttpsc.pl. Quick intro to Transition Technologies PSC. We are a global solutions integrator. We have people working around the globe helping our customers in their digital transformation. We successfully helped many customers adopt to the new Industry 4.0, which focuses on digital thread, where information from every product lifecycle stage is fed back to improve it. From design, manufacturing to sales and maintenance, everything is getting better with the new data that is collected. At TTPSC, we also help businesses to extend their creativity and be one step ahead by understanding their pain points and be customer centric from the very beginning of our cooperation. IoT is just one branch. We also work with PLM or product lifecycle management systems. We have dedicated cloud team and R&D department. We have strong partnership with best-in-class corporations like Amazon or Microsoft, which makes us right choice whenever digitalization is a key. I do Internet of Things, and IoT is an ecosystem of interconnected devices and systems. Data is exchanged and processed to extract the value. Seeing into what is happening in real time gives great overview of current conditions and helps optimize what we do. Everything starts with a connection. Assets around the world can be connected to IoT platform and send data from sensors. IoT spreads across different areas. We have smart cities, smart factories, smart homes, smart energy, and many more smarts. Smart Factory, for example, helps to optimize production by enabling real-time monitoring and KPI calculations. Energy market is moving towards the renewable energy sources. Wind and solar farms optimization plays a major role in balancing the grid, which in turn makes our lives better. Smart cities, on the other hand, are the concept of optimized energy consumption and the reduction of a carbon footprint. That is why we introduce the concept of a digital twin. We have a physical device, its virtual representation, and most importantly, the connection between those two. Physical device sends information from sensors and on-the-edge computing to the IoT platform where it is stored and can be further processed. On the other hand, we have the virtual device which can control the physical counterpart by sending instructions to restart, reconfigure, and so on. Just think of a smart car. It collects data about current fuel consumption, geoposition, and many others. The fleet management system receives the information with ability to see it live on a dashboard and can, for example, lock the car remotely if it's not used anymore. Summing it all up, IoT is all about data. We receive information from devices, user inputs, we connect different systems. Data flows over the network, and processing gigabytes of information every minute is difficult on its own. Here is where Apache Ignite shines. We can incorporate distributed computing and quick data access with in-memory caching and a data grid. If we just look at these zeros and ones, it doesn't actually mean anything. That's why we need to put it into the context. You might be surprised how a simple dashboard, which just shows the current readings from the sensors and how it's been changing over the span of hours or days, helps understand the current situation. It brings the value as it enables proactive maintenance. Operators on the shop floor can react on failures when they happen. And this is just the beginning. With the data analysis, we can predict the failure before it happens. And this could be critical with medical equipment. Important part of every IoT project is a central platform where data is stored, transformed, visualized, analyzed, and finally mined for a value. A great example of enterprise-grade platform is ThingWorx from PTC. It provides us with connectivity features. It supports hundreds of industrial drivers and protocols, REST and WebSocket, as well as MQTT. You can connect anything that uses modern networking. Second part is rapid development that allows to create business logic with just a few lines of code. We can react on data change, connection drops, implement code on the fly, and extend its base features with extensions. It is like creating a building blocks and stacking them on top of ThingWorx. Data visualization with simple drag and drop widgets creates possibilities for remote monitoring, maintenance, and optimization. ThingWorx also implements complete permissions model to make our solutions secure. As a result, customers can open up on new markets and possibilities. Solutions can be implemented and prove the value in weeks, not months or years. Businesses can optimize production, increase productivity, and improve quality. ThingWorx opens the door for Industry 4.0. This is the concept of leveraging interconnected systems, processes, machines, devices, and assets to improve overall productivity. Factories can manufacture better products quicker, have less waste, and optimize not only manufacturing processes but also designing process with simulation capabilities. Maintenance stage gives a lot of insights into how the products are used by customers, and that helps to create better tailored products that meets customer needs. We often use a term smart factories to describe Industry 4.0. Automation and robotics is already there and was introduced with the previous industrial revolution. Today's worlds require more to fulfill growing demands. Companies can reduce cost by increasing quality. Production effectiveness is a key, and an unplanned downtime put it into danger. IoT addresses all of these points. I talk about a lot about smart. For me, it is making decisions based on the current situations. This involves data collection, and we must make sure it can be accessed at any time, and we simply cannot afford any performance drops. ThingWorx active clustering uses Apache Ignite to make sure data is synchronized between nodes. This gives us a lot of possibilities. First, high availability. I've been working with 24/7 services where any unexpected downtime was a real cost to the customer. Number two, data aggregation. We can view changes in how our devices are doing in a span of months and years, and this leads us to number three, which is better quality and quick return in investment. ThingWorx is storing the data in a database, and that's cool, but it is slow. Please keep in mind we process gigabytes of data every minute. So to optimize data persisting, ThingWorx is queuing data and inserts it in a batch. This helps with inserting, but the data still needs to be available. We need to decrease latency, and this can be done with Apache Ignite's in-memory caching. It is even more important if we set up a ThingWorx cluster. High availability and the urgent need for data processing make a reasonable choice to set up a cluster. Here we have two options. First, active-passive, where there is only one active instance handling all the load. Other instances wait until the one breaks so they can take over. Second option is active-active. where all instances are actively handling the load. It gives even better high availability and scaling options, but also is more challenging. Data must be synchronized between nodes, so when certain request is handled by one instance, all information that such a request sends will be available for all other instances. In active clustering, all requests go through a load balancer. No matter if this is the live metering data from devices, user input, or data pushed from other systems, it will be redirected to individual ThingWorx instance based on a load balancing mechanism. In such a case, ThingWorx will use Apache Ignite distributed cache to synchronize information between cluster nodes. Great thing about Ignite is its ability for auto-discovery. Adding new nodes to the cluster is easy and does not need any additional configuration. Historically, ThingWorx will use Apache Zookeeper as a service discovery when attaching new nodes. Zookeeper is also used for a little selection so that every cluster has a main node which will hold all the configuration changes and use Zookeeper to distribute it among other nodes. In-memory cache is just one thing. It is great for speeding up data access, but the real value of Ignite in IoT lays in distributed computing. KPIs like OEE or overall equipment effectiveness, MTBF or mean time between failures, and MTTR or mean time to repair are helping optimize the production. Calculating such KPIs live and comparing them between different factories, shop floors, or individual machines is a great opportunity to find bottlenecks. An example could be finding out that the lower production performance on one line is due to underqualified personnel. Annual and quarterly reports help make the right business decisions. But think of a scale. Devices generate millions of data points stored in time series database every day. In a scale of a year, it could be billions of rows. Again, we can distribute the reporting in Ignite cluster. We like Ignite because it makes so easy to distribute computing, and in IoT platform like ThingWorx, where code can change frequently, the peer class loading is essential. The problems we solve with IoT can make a very interesting business logic. Reacting on data changes, new connections, or doing the right thing at the right time is important. I remember a situation where a customer was reducing the cooling in their freezers when the outside temperature went below zero, or increasing the cooling during the lower energy tariff. Ignite is helping IoT making decisions, which could lead us to predictive maintenance. The big problem of every business is unplanned downtime. It is not only the software bug, machine malfunction, but also a random situation like power outage. Every time it happens, the companies are losing real money. Predictive maintenance addresses all of these concerns. Collected data is analyzed to spot malfunctions or situation that does not fit the pattern and raise alerts and call for action. It is much more than just exceeding the threshold. This will raise a lot of false negatives. And we don't want to send an engineer every time it happens. We want to fix the problem before it even takes place. Again, Apache Ignite helps us with data analysis. The different sources and amount of data we receive require computing power, which is given us by Ignite Compute Grid. But that's just the beginning. We can make a step further with machine learning. Building big models require big amounts of data, and IoT is a great source for it. If we mix that with the computing power, we receive a base for autonomous decision making. Machines can decide to decrease production of a certain part if the next assembly step cannot be finished because of a lack of resources or other parts. This can lead to reducing scrap and save money at the end of the day. Autonomous vehicles can optimize roads and logistics. Reducing travel distance and choosing the best path to maximize the value again saves the money. Internet of Things is a great source of data. It could be usage information, production details, current readings from sensors. All of that helps make our lives better. We, as customers, receive better products. Companies that manufacture them reduce the cost and increase the quality. Smart cities help reduce carbon footprint and release of greenhouse gases to the atmosphere. Energy supply and demand can be balanced, which is very important because we still are not very efficient when it comes to storing the energy. All of this require data, which must be available at all time. Decisions taken now will affect tomorrow. Any performance drops or downtimes are not acceptable. Broken up medical devices may be disastrous, and preventing that happening could save lives. The world we live in is changing with IoT, and Apache Ignite is used in one of the biggest enterprise IoT platforms out there. It helps us implementing software for a better future where devices and systems connected in the network help us making decisions for a better tomorrow. I hope you enjoyed the journey into the IoT world as much as I did a few years ago. Thank you for today, and let's keep in touch. Thanks.
Piotr, welcome back.
Hi.
Hey. So, is the Internet of Things as fun to work in as it sounds like?
Yes. Yeah. And the great thing about IoT is that you can actually see it is making a change when you implement solutions like I don't know, just simple remote monitoring. Like you see the data that is coming from the sensors on the live dashboard, and it already gives a lot of possibilities. Like operators can just see what is going on the shop floor. Like historically, they just need to go and check how the machine is working on the panel on the machine. But right now, they can only just have a dashboard and have an overview of all the machines in one place. So I think the best thing about IoT is just you can actually see it changes someone's lives by enabling this kind of uh, data collection and using it, right?
But there's another side to this data collection, isn't there? Which is
Mhm.
that there are a couple of sides. There's the security side, and there's the fact
Mhm.
that we're so connected now. We all have devices that are gathering vast amounts of data. So that leads us to one of the questions, which is, where do you see the biggest potential for data mining?
That's a really nice question. So I think it can be actually everywhere, but from my experience, the smart factory and in general industrial IoT is a great opportunity for this because by just looking into the historical data, historical values we collected throughout the process of producing a particular product, we can improve it. And really great here is the digital thread I mentioned. So, for example, if we know how our users are using the products we produce, we can just make those products better because we know that, for example, one of the features is being used extensively, so we can improve or put more effort to make it better. Or if there is such the feature that is not being used very frequently, we might just extend it or just change it with something else. So I think the biggest potential here is in the industrial IoT and the factories that actually produce something. But on the other hand, I really had I was really surprised. Like for example, I've seen last once on the customer that were using the electrical vehicles in their factory, and when the vehicle was not used, they could just plug it into the grid on the factory, and just when there is a problem with electricity, those electric vehicles could give the power and the energy to the most critical machines in the factory. So yeah, this is also something. So it makes our production continuous, and yeah, we are reducing the downtimes, which is also really a big problem. And it's in IoT, it's like pretty common problem.
I think that's something that Elon Musk was talking about, was ultimately having batteries which are so good. There's the million-kilometer battery that he's working on, that they can just be feeding back into the grid when they're not being used. So effectively, you have an entirely distributed power system, not unlike Apache Ignite being an entirely distributed storage and compute system. Here's a fun question from Jeremy McMillan. What's the smallest IoT device that you've been able to integrate into an Ignite-backed system?
That's interesting as well. From my experience, the most devices we were connecting was one for the medical company. We have more than 100,000 devices connected. I'm not sure what actually they've been using, but it's probably not the smallest we can connect to IoT platform. I know we tried to, like for example, use the ESP32, which is quite small, I think. But yeah, this is like we tried to simulate some of the data that could be sent, and yeah, do some calculations based on that. So ESP32, but there is definitely something which could be even smaller, and like many, or I think every IoT platform, not only ThingWorx, but every IoT platform will just support REST APIs. So anything that is capable of sending the HTTP request should be ready to connect to IoT. So it's I don't know, maybe it's too narrow, but I would say that there is no limit in the size of the device that can be connected.
No, it'll be interesting to see how small things go. I remember years and years ago, I think it was Sun who had at one of their early Java conferences. They had a ring, and I think all they did was they just had some data on it, which would just be able to store how it was that you liked your coffee. We've come a long way since then. I have another question for you from our list. What could be the next steps in utilizing Apache Ignite in ThingWorx? Is there a next level? Is there a way further development that you can see happening?
Definitely. The thing is that the compute grid I've been talking about is more like an extension to ThingWorx. ThingWorx is not using compute grid, and it could, right? So a lot of the out-of-the-box things that is going on, they are still computed just, let's say, the regular way. And I think we could make more use of this compute grid using Apache Ignite, so that we don't need to do all the heavy logic, like for example filtering the data or some business logic. We don't need to do it on ThingWorx on the same server and all this kind of stuff, but we could utilize compute grid and out of the box ThingWorx functionalities. Because at this point it's more like an extension. So what we built on top, we use compute grid. Yes, I think this is something that I think ThingWorx should utilize. So using the compute grid for doing its own business logic.
Right. Another question. Where else have you used Apache Ignite? Not if you came to it from ThingWorx, where else have you used it?
Yeah, so at the very beginning, I also mentioned I've been teaching Apache Ignite at the university, so this is one thing. We also had this case. It wasn't quite IoT yet, but we had to calculate a reporting for OEE KPI. Like we have this information. I think it was a minute resolution, and for the past year, it was like I don't really remember, but some kind of billion rows to calculate to just aggregate this and have like average for every month, so they can compare it. So we used also Apache Ignite there, and yeah. But I think the biggest fun for me was teaching this at the university and just seeing people being amazed how we can reduce the computation time for a particular use case. So I also had this situation where we actually went down from 9 hours calculating some business things to just half an hour. So 9 hours to half an hour, and also could be optimized even further if we could just yeah, add some new additional nodes to the cluster. So yeah, that's pretty much it.
And numbers like that are actually not that rare.
Yeah.
Using compute grid and affinity and good design with Apache Ignite, or certainly improvements like that, are not that rare. Do you have any numbers where a single instance of the cluster would not be enough?
Oh yeah. So ThingWorx makes it pretty straightforward. So we have a formula to calculate a request per minute. And there is also a table which matches the number of requests per minute to the instance. And it's from small, medium, large to extra large. And just to give you some context, the extra large is 32 virtual CPUs and 128 gigs of RAM. So for one of the projects, and it was quite recently, like 2 weeks ago, we used this formula, and the extra large is for 200 requests per minute, right? And based on the formula, we calculated, and for us it was 4,000. So the extra large, which is already quite powerful, was capable of handling this 250 requests per minute, and it was just requests from the users. And then we also have a different formula for devices connected. So yeah, it was like definitely something we could probably make or find a bigger instance for that, but it's not very good solution to this problem. So what we did, we just introduced a cluster. So at least based on my experience, if we have like 200 requests per minute or 250, it is maximum for a single instance, and then we should think about a cluster of nodes.
Okay. And here's what might be a final question. And in fact, it's the first time the D word has come up today. And by D, of course, I mean Docker.
Yeah.
Did you consider using Docker containers? And what's been your experience with using Docker setting up a cluster?
Yes. So ThingWorx is Docker ready, but I haven't seen this in production yet. But what I think is great about having or developing with Docker is that it's really easy to stop the instance and just recreate it and have a fresh and brand new development environment. So I always use Docker for developing anything, and it's really easy to scale using Docker and adding new nodes and Apache Ignite. I really like it. So yes, we have considered this. I also created some images. We are testing them at the moment. So we want to test our images, how it will work when it comes to connecting real devices and all this kind of stuff. So yes, we are using Docker with ThingWorx, with Apache Ignite. For now, it scales really nice, and the results are very promising. So maybe, and I hope, sometime in the future we will see ThingWorx and Apache Ignite working in a Docker cluster in the production.
Okay, great. And now there's one last question. I think we're going to make it the last one from Francisco Molina. I'm going to show that. The question is, how often do you use Apache Ignite in ThingWorx projects, given these numbers that you just mentioned?
Unfortunately, not that often. This is something I think maybe I should start about explaining what I think the technology evangelist means. And for me, it's just spreading the knowledge about the technology, the processes, the best practices on all this kind of stuff within the team, but also outside of the team. So I want to make sure that everyone knows we do IoT and we do it well. And this is, I think, my role at the moment to make sure that people understand why Apache Ignite is so important with ThingWorx, because we are seeing the projects and we are trying to connect more and more devices. So it's like essential to have this in the cluster environment. But still, this is something we need to encourage people to, or our architects to consider this as a solution. So it will grow. I guarantee it.
Great. Okay. Well, Piotr, that's brilliant. Thank you so much for all of your time and for your talk and for the Q&A. It's really fun. And so I'm going to bid you farewell for today. And like I said, there's still a few good talks, so I hope you'll stick around for a bit and enjoy them, since you're a big fan of Apache Ignite. And I hope that we can talk again soon, especially about teaching people